guys. Okay, so this is going to be part 2 of the slope videos. So part 1, if you haven't watched part 1 video, you need to close out of this and watch that first, okay? Part 1, we talked about slope dude, how to identify positive, negative slopes that end up as 0, and then undefined slopes. So we've been talking about why that's undefined. And then we also wrote down some steps on how to find slope from a graph. So we're continuing these notes. Now we're going to talk about how to find slope from a table. So that's the next thing in there. And we are going to add this. I know it's probably somewhere in your notes, but maybe not. Okay. So in class the other day, we talked about how slope is actually the same thing as rate of change. And rate of change, how we learned that a few days ago, rate of change, was we found the change in y over the change in x, delta y over delta x, right? And then if you were paying attention in class Thursday and Friday, I also told you that there's a fancy letter. It's not fancy, it's just letter. There's a letter that we use to represent slope in algebraic equations, and that's the letter M. And you're going to see that come up on the next page, okay? But all of these things mean slope. They represent slope, okay? So why don't you go ahead and highlight that, put a box around it, whatever you need to do. Okay, all of those things mean the same thing. Okay. Okay, so we're finding slope from tables. So obviously we're going to be drawing some tables here, some X, Y tables. So let's get our first one set up. X, Y. We have 1, 2, 3, 4, 5. We have 5 ordered pairs in here. So get your table all set up and pretty. Okay. And now let's go ahead and plug in some ordered pairs. And by the way, pause the video if I'm going too fast, right? So here's your first ordered pair. -4, 3. -3, 6. -2, 9. 0, 15. And 1, 18. So directions on this would be find slope, right? Find slope. Well, slope is the same thing as rate of change. And rate of change is just change in y over change in x. So that's what I need to find, change in y over change in x. So that's the little, little triangle things off to the side, right? So let's go ahead and do that. So I'm going to first start with this right here. The change in y from 3 to 6. From 3 to 6, that is increasing by 3. Okay, so I go right here, I put a 3. From -4 to -3, so I've jumped over to the x side, so I have to find my first change in x. From -4 to -3, that's actually increasing. It's getting closer to the positives, right? So it's increasing by 1. It went up 1. So that's a positive 1. +3 divided by +1 equals 3. Okay. Now, do we have to check that all of these end up as simplifying to 3? Yeah, because we do need to know if it's linear or not. If it's not linear, which is what we were checking, last week, if it's not linear, then it's not going to have a constant rate of change. Therefore, it doesn't have a slope. Okay. So let's check the next little comparison. Change in y from 6 to 9, that's increasing by 3. From -3 to -2, that's increasing by 1. I take my change in y, divide it by my change in x. So change in y divided by change in x. 3 divided by 1 is 3. It's looking good so far, right? Still got to keep checking it though. From 9 to 15, is that an increase of 3? No. That went up 6. 9 plus 6 gets us to 15. Let's check the x values over here. -2 to 0, that's an increase of 2. 6 over 2, so my change in y divided by change in x. 6 divided by 2 is 3. I got one last one to check. First of all, change in y from 15 to 18, it increased 3. Over on the x sides, from 0 to 1, it increased 1. So my last little division here is 3 divided by 1, which is 3. So they all end up with a rate of change of 3. So one thing we could say, a true statement, is that this table has a constant rate of change. We could also say that this table is linear because it has a constant rate of change. You could also tell me what the rate of change is. What's the rate of change? It's 3. Rate of change is 3. Now, guess what? If I ask you the slope, well, slope is the same thing as rate of change. So if your rate of change is 3, then your slope is 3. Okay, so you're just going to give yourself a little note off to the side. And we're going to say this, a constant rate of change makes the table linear, comma. The constant rate of change makes the table linear, comma, but it also tells you the slope. Okay, so in this case, if my rate of change equals 3, then my slope equals 3. Okay, and if you want to be super fancy today, instead of writing slope every single time, try and get in the habit of writing m, okay, because that's what we're going to start using a lot. So you could say m equals 3 in this problem. Okay. Okay, so now we're going to do some practice. And I'm going to highly recommend that once you get the table written down, you pause the video, try it on your own because you've already done this, right? And in fact, when I go to edit this video, I'm probably going to fast forward the recording so that you can just copy it down, try it out, push play when you're ready to check your answer. Okay, so XY table. This one also has 5 rows. You know what, let's just do, we're just gonna do 4 rows. First ordered pair 8, 2. Next is 6, 3. 2, 5. And 4, 4. Go ahead, try that out. Find the slope. You're looking for change in y over change in x. Push play when you're ready to correct. Okay, so I'm going to start with my change in y, this first comparison right here. So from 2 to 3, that's increasing by 3. And in fact, I'm just going to get all my y's done. 3 plus 2 is 5. And then 5 to 4, it went down 1. That might mean this table is nonlinear, but we can't state that right away. We have to see what happened on the change in x side as well. You have to compare it to the change in x. So over here, from 8 to 6, that's a decrease of 2. So it's going down 2. From 6 to 2, that's a decrease of 4. But from 2 to 4, that's an actual increase of 2. So there's some weird things happening, but we cannot say whether this is linear or non-linear yet because we have to do the comparison of change in y over change in x. Have to. So let's go ahead and find that for each little set here. So we start with the first one. Your first change in y was +1. your first change in x was -2. So that's just a fraction. That's -1/2. If you want to stick the negative out front, you could. So that equals -1/2. Okay. Now we go to our next little comparison. Always put your change in y on top. Okay. Change in y was +2. My change in x was -4. Does this simplify? Yes, it does. 2/4. Well, 2 is half of 4, right? And I stick that negative out front. 2/4 is the same as half. So -2/4 simplifies to -1/2. Okay. Then let's go ahead and do this last comparison. We take our change in y, which is -1, divide by +2, and oh my goodness gracious, that also is just -1/2. So all of these simplify to -1/2. So that obviously means it's linear, okay? But it also tells you the slope. So in this case, we know that the slope is -1/2. Okay. Okay. Here is number 3. I'm going to make sure I give myself room for number 4. Okay. Okay. Number 3, here we go. Set up your table. X, Y. Let's do 4 values. And while you're at it, you might as well set up this table. Okay, here's number 3. So ordered pairs are 3, 4. 3, 6, 3, 7, and 3, 10. Right away, I noticed that all of the x values are 3. So this might be one where if we graphed it, maybe it's horizontal, maybe it's vertical. But you'll see in the math that we do here, when we do change in y or change in x, we'll see what happens. If you want to, maybe pause it, try it out yourself, okay? If not, let's go ahead and let's just figure out all of our changes, okay? You can do it one at a time, y, x, y, x. I'm just gonna do it all at once. So on the y value side, from 4 to 6, that's an increase of 2. 6 to 7, that's an increase of 1. 7 to 10, jumped up by 3. Over on the left-hand side, from 3 to 3, that's a change of nothing. 3 to 3, 0. 3 to 3, 0. So when you go to do your change in y and your change in x, let's see what happens. I have 2 over 0. Uh-oh. 2 over 0. If you were to put 2 over 0 in a calculator, is that 0 or is it an error? Remember, 0 can't be on the bottom. That's no. That's N-O, no. 0 can't be on the bottom, okay? So this would actually result in an error. And if you check these other ones, 1 over 0, 3 over 0, all of those would end up being an error. So what do we write for our slope? What's our slope here? Slope is undefined. Okay, so that's going to happen every once in a while, right? It's going to happen. That's fine. Okay. All right, let's do another one, number 4. And you know what? Number 4 is going to be one of your entry task problems. So I'm going to give you the values, but I'm not going to correct it in notes today. So that'll be the first problem you enter on your entry task. So here you go. -3, -5, -1, 0, 3, 10, 5, 15. Okay. So that, do all the math, find the slope. Slope is what you're going to enter in on the entries. Okay. Okay, now the last piece of this, we've done slope from a graph, slope from a table. So the last thing I need to teach you is how to find slope from 2 points. How to find slope from 2 points. So 2 points meaning 2 ordered pairs, 2 x, y values. Okay, so if I give you 2 ordered pairs, you got to be able to find the slope. One way you could do it is you could plot the points and then find the rise and the run. But that might not be the best solution, especially if you have large numbers that you don't really want to plot on a big graph. Okay, so there is a fancy slope formula. We need this in our notes. This is important. So we are going to name it. This is called slope formula. That is what it's called. And it is going to look like the most weirdest thing you've ever seen in my class so far. Just being honest. It's going to look crazy and scary, but it's not. I'm going to break it down and I'm going to show you it's literally what we've been doing this whole time. Okay. So here's the slope formula. M equals, there's that M. That's why we have to know it. You have to know that this M is really just slope. Okay. So here's a formula. Formulas, by the way, in mathematics, formulas like to use a bunch of variables. Okay. So here is your slope formula. You're going to put a big old fraction bar. On top, you're going to take y, but that y, we call it a sub 2, meaning it's not an exponent of 2, it's actually below it. It's called y sub 2. You're going to take y sub 2 and you're going to subtract y sub 1. Huh? Don't worry, I'll explain it, okay? And then in your denominator, you're going to take x sub 2 and you're going to subtract x sub 1. What? Don't worry, I'll explain it, promise, okay? But this is the slope formula, okay? So really, let's kind of talk about this. I'm going to point to this M. I suggest you write this in your notes. M, what is M? M is just slope, okay? We use M to represent slope in algebraic equations. If you want to write that statement I just said, pause the video, write it down. We use the letter M to represent slope in algebraic equations, okay? On this side, if those 2's and 1's were gone, it would look like y minus y. You know what that is? That's just the change in y. You're taking your second y value and you're subtracting your first y value. Really, that's just the change in y. So I'm going to write change in y. And then at the bottom, x sub 2 minus x sub 1. Really what that means is you take your second x value and you subtract the first x value. When you take the difference of something, of two things, you're finding its change. So that's just the change in x. So I promise you, you've already kind of been doing this. We just haven't really seen this put in a formula format, okay? So let me give you an actual example problem. So this is your example here. So it would read something like this. So write these directions down. We're not going to write it every time, but we're going to write it this time. So the example would say something like this. What is the slope of the line? What is the slope of the line that passes through and then I'm going to give you 2 ordered pairs. So what's the slope of the line that passes through? So it passes through 2, 6. So the ordered pair 2, 6. And 1 comma 4. So we're trying to find the slope of the line that passes through those 2 points. Now, could we make a graph 2, 6, graph 1, 4, find the rise, find the run? Yeah, we could, but you need a different strategy, because if that was 205 comma negative 6,000, you would not be wanting to graph that, right? So we use this fancy formula. Okay, well, 2, 6, so hopefully you have some space right underneath 2, 6. I want you to tell yourself, this is your first ordered pair. It's the first ordered pair that was listed in the problem, right? Since it's the first ordered pair, I would call this x sub 1, because it was the first x value you saw. And that 6 would be y sub 1. Because remember, ordered pairs are x, comma, y. Since it's the first ordered pair, though, we put the little sub 1s underneath it. What that means is the second ordered pair, what do we call those points? Well, the 1 is your x value, but since it's from the second ordered pair, that's your x sub 2, which makes the 4 your y sub 2. So when you go and use this formula, all you're going to do is plug in the right numbers to the right spots. So let's go ahead and let's use this formula. Your first number that you're looking for is your y sub 2. Look at our values. Where was your y sub 2? Y sub 2 was here, which was the 4. It's your second y value. So my second y value was positive 4. And according to the formula, I'm going to subtract whatever y sub 1 was. So locate your first y value, 6. So we have 4 minus 6, okay? Now we're going to look at this, x sub 2 minus x sub 1. So you take your second x value, which was right here, and you subtract your first x value, which was 2. So now we just got to do some math here. Get a calculator if you need to. 4 minus 6. What's 4 minus 6? Negative 2. 1 minus 2. Negative 1. And you check to see if you can simplify. Okay. Negative 2 divided by negative 1 is positive 2. Okay, negative divided by negative, positive. All right, so your slope, your final slope here is 2. Okay, the slope of the line that passes through these two ordered pairs is positive 2. It's going up 2 over 1, up 2 over 1. Okay, now if you're thinking, what in the bejesus just happened? I want to connect this to what we've been doing with tables. I want to connect it, and you'll go, oh my God, that's so weird. Okay, I hope you say that. Make the easiest little table you've ever made. Okay, let's plug in those 2 points, 2, 6, 1, 4. Let's do it the old school way, changing y over changing x. You're changing y from 6 to 4. I make you think of it as a, how did 6 become 4? It subtracted 2. Right? Well, another way you could have got negative 2 is you could have took your second y value. That's your y sub 2. You could have took your second y value and subtracted your first y value, because 4 minus 6 is negative 2. Okay? When you go to find your change in x, from 2 to 1, I just think about, like, how does 2 become 1? Well, it just decreases by 1, right? But you could have also taken your second x value and subtracted your first x value. 1 minus 2, negative 1. So your change in y over change in x would get negative 2 over negative 1. And negative 2 divided by negative 1 is positive 2. Either way, you still got 2. Okay. So it is the same thing. It's just a different way of showing it. And yes, you need to know how to do both. Okay. Okay. So we still need to know the slope formula. So we're going to call this 5. Okay. So instead of writing this statement every time, I'm just going to give you the 2 ordered pairs, but you are trying to find the slope of the line that passes through the given points. So here is your first, here's your first ordered pair, 5, 2, and -1, 5. So we're finding the slope of the line that passes through those 2 points. Okay. Okay. So if you need to, some of you might need to label. Here's your X1, here's your Y1, here's your X2, here's your Y2. Some of you might need to label that, especially when you're starting out, okay? But we are going to use the slope formula, okay? Big stuff here. So look at your formula up top. I take my second Y value. What's the second Y value? +5. And I subtract the first Y value. First Y value is 2. Now you take, we're on the bottom now, take your second X value. It's over here, -1. We're going to subtract the first X value, which was +5. Okay. And then we just do some calculations here. On top, 5 minus 2 is +3. -1 minus 5, be careful, use a calculator if you need to. -1 minus 3 is, or minus 5 is -6. Okay. But you always, always, always need to ask yourself, can you simplify? So can this fraction be simplified? You better not say 2. It's not 2. 3 out of 6 is equivalent to half. So my final answer would be -1/2. Okay. If you're struggling with simplifying, that's not something covered in my class. You need to YouTube videos and say like, how do I simplify fractions? Search that up, watch some videos, okay? Number 5, not number 5, number 6. Highly recommend you try this one on your own, okay? Here you go, -8, excuse me, -1, 8. That's your first ordered pair. Second ordered pair is 3, 4. Pause the video, try it out. Okay, so I know this formula pretty dang well because I've been doing it for 5,000 years, right? So I just know that I start with this second piece, the second order pair. I take my second Y value, which is 4, and I subtract my first Y value, which is 8. So 4 minus 8 should be going on top. On the bottom, I take my second X value, which is 3, and I subtract my first Y value, or first X value. This is where kids mess up. If you put a 1 here rather than a -1, you're going to get the wrong answer. Okay. So notice how in the formula you have to subtract, right? But if you're subtracting a negative, be super careful. Subtracting a negative is like adding a positive. So 3 minus -1 is the same thing as 3 plus 1. 3 plus 1 is 4. Use a calculator if you need to. On the top, 4 minus 8, that's going to get in the negatives, right? 4 minus 8 is -4. So you have -4 divided by 4. Obviously, you need to simplify. -4 divided by +4 is -1. Okay. Okay, I've got 2 more to do. Here's number 7. Number 7, your first ordered pair is -2, 5. Your second ordered pair is 7, 5. Pause the video, try it out. Okay. So I take my second Y value, which is 5. And I subtract my first y value, which is 5. For the denominator, I go to my x's. I take my second x value and I subtract my first x value. So on your paper, it should read 5 minus 5 over 7 minus negative 2. 5 minus 5 is 0. 7 minus negative 2 is the same thing as 7 plus 2, so that's 9. But is this, I see a 0. Remember, 0 on top is okay, right? 0 on top is fine. 0 divided by 9 is just going to be 0. So your overall slope here is just 0. Okay. Okay. This last one is a question for you to do. You're going to enter it in your entry task. So you got 2 practice questions, right? You have number 4 and number 8. So here's number 8. 4, 8 and 4, 11. You're going to find the slope of those 2 points. Okay, there you go. That's it. We will practice more in class. See ya.